Welcome to this demonstration of using Autodesk Nastran in Inventor. During this video, we'll discuss the life of the fork crown on this bicycle suspension. Where are the high stress concentrations, and how many load cycles will it handle before cracks begin to form? For the purpose of this analysis, we only need to focus our attention on the fork crown and hide the other components. Autodesk Nastran is fully integrated in Autodesk Inventor. There is a Nastran tab in the ribbon, as well as the FEA browser for easy setup of the analysis. Let's begin by setting up a linear static study to analyze this baseline design. We can use the material directly from the CAD model or choose a different material from the Autodesk library. Here, we'll also specify the part we're going to analyze and confirm the material and type of elements we're going to use. For the boundary conditions, we'll constrain the two holes that are tightened down to the rods for each strut. Then we'll apply a large force as a factor of safety for the center hole. Before running the study, we'll mesh or break the model up into several pieces to be analyzed. The amount of time it takes to create the mesh and run the analysis is about 20 seconds. Let's take a look at the von Mises stress plot to find where we may have areas of concern. We can see that the highest stress in our model is 37 megapascals. That is low enough that we could make changes to the design that would provide a lighter component for the bike. We'll open up the part from the main assembly and edit some of the dimensions. Notice we can do this right inside Autodesk Inventor. The updated model will be remeshed and reanalyzed without leaving the CAD design environment. Every time a design is analyzed in Autodesk Nastran, there are hours or even days that are saved as opposed to creating a physical prototype for testing. Back in the main assembly, let's update the analysis results for the new design. Back in the stress plot, we can see the results have increased as expected. The question now is how long will the part last? We know that 130 megapascals is past the endurance limit of aluminum. Let's change the study type. There are two fatigue options for static loads, as well as fatigue based on a random vibration analysis. We'll pick multi-axial fatigue for this scenario. There are a few changes we'll make to the setup, starting with the material information. The fatigue curve contains two options for stress life or strain life for high cycle or low cycle calculations. Here, we'll input some of the known material information such as the slope, stress, which is sometimes ultimate stress, and the corresponding number of cycles, the endurance limit, and slope after that value, which is often close to 0. There is also an option for the K factor when accounting for surface finish, corrosion, and other existing conditions for high-fidelity results. We'll take a look at the chart to ensure that the results we entered visually look correct. There is an additional option for load history in fatigue studies. Here we will describe the behavior of the load, whether it's applied in one direction, fully reversed, or sometimes higher in one direction than the other. After the values are applied, there is a chart to ensure they have been entered correctly. Finally, before we run the analysis, we'll specify the stress results from the linear static study to use between von Mises, principal, or shear. There are other settings available for how the results are displayed in terms of the number of cycles or time such as years to fatigue failure. The fatigue study results are calculated extremely fast. Almost all of the 20 seconds to solve are spent on the linear static results. We can now take a look at the life plot to find out how many 5,000 Newton loads the fork crown will handle before cracks begin to form, and ultimately cause the part to break. We can see here that the number of load cycles is 322,000. With a very large load condition, we can consider the part to be safe for normal use. Remember that changes are made right here in Inventor. We may decide to edit the model several times for a better design. As you have seen, this analysis solves in less than a minute. Oftentimes, there is no need to leave your desk to wait for the results. Autodesk Nastran provides powerful digital prototyping technology, saving time and money for innovation on your designs.